Okay, so we are going to just do two quick applications. So this one is a very famous one. They love this on math. You got this open box that is to be constructed from a 12 by 20 piece of cardboard, cutting equal size squares from the corners and folding up the sides. We've kind of done one similar to this. So draw it out at least. If you have a box, and the dimensions of that cardboard box are 12 by 20, and you're going to cut out squares from each of the corners, and they're all equal size, but you don't know their dimensions. Call it X by X by X. Okay, what does that leave for this length? Well, if this whole side is 12 and you cut away X and X from it, this side right here would be 12 minus 2X. And if this whole side is 20 and you've cut X away from it this way and this way, you would have 20 minus 2X. So if you were drawing this like a box, think about it like this. It's a terrible box, but you have this 20 minus 2X side right here. And then back here, you have that 12 minus 2X. And then this height right here is X. So the first question will be, okay, find the volume. Well, volume is easy. It's just length times width times height. So length times width times height would be 20 minus 2X times 12 minus 2X times X. Now, yes, you're going to have to FOIL it. But to save us time, I'm going to pre-FOIL it for you. But you will get 4x cubed minus 64x squared plus 240x. That is part A. Now, part B, give restrictions on x. So again, all of our factors here, all of our side lengths have to be bigger than 0. We can't have a side that's equal to 0. So our restriction would be that x has to be bigger than 0, that 20 minus 2x has to be bigger than 0, and that the 12 minus 2x has to be bigger than 0. So let's see if we can solve this one more. 20 is greater than 2x divided by 2. 10 is greater than x, so x has to be less than 10. On this side, 12 is greater than 2x divided by 2. 6 is greater than x, so x has to be less than 6. Ooh, so what do we have here? So we want to see where all of these three are going to overlap. If my x values have to be bigger than 0, but less than 10 and less than 6, where would that overlap be? Well, wouldn't I choose the less than 6 and the greater than 0 part right here? This is where it overlaps. My values would have to be that x would have to be bigger than 0, but less than 6. If I am greater than 0, but my values are less than 10, according to this one, I can have values less than 10, but according to this one, I can only have values less than 6. So I need to choose the less than 6, but the bigger than 0. Okay, it has to be positive. So I wouldn't be able to have a 7. It would make me, if I had a 7 right here, that side would be -2. So it doesn't work out. So those are the restrictions on x. Now, determine the values for which x is maximized. So we're going to use our calculator for this, or in this case, am I going to use Desmos? And I'm going to type in that equation that I just had before. And to be honest with you, you could probably type it. You know what? Let's just do it. Why not? If I mess up, it's on me. 20 minus 2x, 12 minus 2x, and x. Okay, I got something here. Let's see, let's zoom out a little bit. All right, let's see. Now, I only want values that are between 0 and 6, so really only between here and here. So let's change my window for x. Let's go 0 to 6. Let's see if that does anything for us. I might have to, it didn't really give me some y values, so I might have to zoom up a little bit just to see. Oh, there we go. What's the y value there? 262. All right, so let's make this a little bit nicer. Let's change my wrench to be 0 to 6 again. And oh, look at there. Now they did it. Thank you. Thank you, Desmos, my friend. 0 to 6, and then look, they did that for me. Look, they found the max, and I didn't even type the equation correctly. I just typed it as a factored form. I love this thing. The graphing calculator can do that too, by the way, but not as quickly. But look at that right there. 262 and 2. That is the maximum from 0 to 6. So let's go back to this question. Determine the values for which x is maximized. So I had this picture from 0 to 6. And at this point right here, that point, I'll write it out for you, was the point 2.43, 262.68. So what does that mean? Because that's important. You need to know what this means. Well, this says when x is my what? X is my side length here. So when x side length is 2.43, I have a maximum volume of 262.68. That's the side length where I would have my highest max volume. That was pretty cool. I give props to you, Desmos. Now let's do this part. For what values of x will the volume be greater than 200? What values of x will the volume be greater than 200? So I'll do it in Desmos in a minute, but we're going back to this picture, 0 to 6. I got my max here, but now I want to find, I want to know what, remember this is my max right here of 262? Well, I want to know when the y values will be greater than 200. When is the y value? What are the x values that make it a volume greater than 200? So I'm going to go back into Desmos and into another line here. I'm just going to write y equals 200. And look at that. They've given me the intersection points, 1.174 and 3.98. So when my x values, when is the volume greater than 200? Well, here's where it's greater, because here's the max. Between here and here, it's greater. So when x is 1.174 and 3.898, that is pretty cool. It did it right away. So this x value here, or this point, was 1.17, 200. And this point right here was 3.9, 200. And so what values of x will the volume be greater than 200? any value where x is between 1.17 and 3.9. That would make a volume greater than 200. You wouldn't want it to equal 1.17 because then it would equal 200. You want it greater than 200. So that one is not too bad of a problem. And I like it. I definitely see it. You'll see it in calculus quite a bit because you'll learn about something called max and mins, optimization, which is maxing and minimizing. All right, and then this one sounds so simple and yet, oh, so fun. A right triangle has an area of 96 inches squared. One leg of the triangle is 4 less than the hypotenuse x. What is the length and what is its length of the leg and what is its domain? Okay, so got a right triangle. I like to draw when I do geometry questions, so I kind of label things. The hypotenuse they told us was x. Sometimes we call the hypotenuse c, by the way. So I'm going to put a little c over there. The one leg of the triangle is 4 less than the hypotenuse. So, I mean, it doesn't matter. I'll just say, okay, 4 less than x. We'll call that A. This will be C. This side, I don't know. We'll call it B. We'll be able to figure it out, though. Let's do part A. What is the length of the leg and what its domain? We just found the length of the leg. The leg is x minus 4. That's its length. Okay. Now, my dog just came in running, and I don't know what he's freaking out about. No worries. The domain of that leg would be, again, we can't have a negative side of a triangle. So we want x minus 4 to be greater than 0. So x has to be greater than 4. So that wasn't too hard to answer. That was a nice one. You could write this as 4 to infinity, by the way. I can't remember. I wrote down 4 to infinity, but I can't remember which way they want it written. Either way, x is greater than 4. Express the length of the other leg in terms of x. So this is not hard, again, because you know Pythagorean theorem, good old a squared plus b squared equals c squared. This time we don't know this leg, b, that's the other leg. So we're going to replace a with x minus 4, square it. B, we're going to leave b because we're going to solve for it. And c, we're just going to call x. And yes, you got to, boil this out or factor this out a little bit. So let's see, this would be x squared minus 8x plus 16 plus b squared equals x squared. Bring everything over to this side. So b squared equals, what would happen to your x squareds? They go away. And you'd have 8x minus 16. And then take a square root. And now don't put plus or minus in front because we're talking about the side of a leg. So b is equal to the square root of 8x minus 16. And we're going to leave it just like that. Now, let's find the equation for the area. This is where it gets super fun. If you know the formula for area of a triangle, it's pretty easy. It's half times base times height. Half times base times height. 1/2 base times height. Or maybe your teacher was said base times height and then divide by 2. It's the same thing. I just like 1/2 times base times height. They already told us what the area was. They told us it was 96 inches squared. So I'm going to put a 96 right here. 1/2 stays 1/2. What's my base and my height? Well, my base and my height of a right triangle, it has to be the two sides that make the right angle. Okay? So and it doesn't matter which one you call base. In this case, I'll just call x minus 4 my base. The height, we just found that expression right here. Square root of 8x minus 16. Now, we're going to have to do a little bit of algebra. You're going to love it. We have to clean this up. First thing I would do is get rid of this 1/2. To undo a 1/2, you multiply it by 2. So then you would get 192 equals x minus 4 times the square root of 8x minus 16. I better leave myself some room because this gets a little bit fun. I tried many ways to do this otherwise, but it's a pain, and they want it in its simplest form. So you're going to have to watch and FOIL. Okay. Do you know how to undo a square root? You have to square both sides. Square both sides. So you have to raise this to a power of 2 and this to a power of 2. 192 squared, I'm just going to give it to you, is 36,864. This x minus 4 quantity squared, that's not hard to do. That's FOILing it out. But I'm just going to write it out just so you understand what I'm doing. I'm taking this part, factor, and I'm squaring it. And then I'm taking this guy, square root of x minus 16, and squaring it. Why am I allowed to do that? Because the rule says, you know, any two numbers that you're squaring, any two things that you're squaring together, you just do a squared times b squared. As long as there's no plus in between. Even though this has a minus in between, this is still a binomial. I can still FOIL this out. This is x squared minus 8x plus 16. This right here, this square root and this squared will cancel. And you'll be left with 8x minus 16, equaling 36,864. Why do they use such big numbers? I don't know. Now, what do I have to do from here? Oh, I have to distribute each one of these to all three of these and distribute that 16. And I'm going to do it because I didn't do it on the last one. So I'm going to force myself to do it. Hopefully I won't make a mistake. So 8x times x squared is 8x cubed. 8x times negative 8x is negative 64x squared. 8x times 16 is 128x. Yes. Negative 16 times x squared is negative 16x squared. Negative 16 times 8x, negative 8x is positive 128x again. And negative 16 times negative 16 is negative 256. Oof. And then what can we clean up? We can put some squareds together, and we can put some x's together. And it still equals 36,864. So this would be 8x cubed minus 64x squared and a minus 16 8x squared, 16x squared becomes 80. 128x and another 128 is 256. And then the minus 256, and let's just, for the sake of time, let's bring that over to that side. So I'd have to minus 36,000 to the 256 would make negative 37,120 equals 0. Now, shockingly enough, every single one of these numbers is divisible by 8. And that would actually be the most simplest form, to divide every single one of them by 8. So if you divided this by 8, you would get x cubed, 10x squared, 32x, and 37,120 divided by 8 is 4,640. That is the most simplest form of that right triangle. Sheesh. It's a lot of multiplying. Hopefully you understood what I just did here. When you're squaring two things that you multiply, you square the one, which means you have to FOIL that because it's a binomial. Squaring a square root undoes it. and then you'd have to distribute it all out. So it's a pain, but you can do it. From here on out, once you get that equation, it's just typing it into your calculator. Oops. And I'm going to type it into good old buddy over here. Let's hit the home screen to make sure we go back. So let's see, x cubed minus 10x squared plus 32x minus 4640. And you can see I'm way out of it, so I kind of got to zoom out. Well, look at there. I found a zero. 20. Use a calculator, solve for x. So x is 20. That's one of them. Obviously, there's probably going to be more, but they would be off my domain here. So if I found my zero, so x equals 20. So if x is 20, then you can plug it right back up in here. This would be 20. This would be 20 minus 4, which is 16. And then to find b, you do 20 times 8 minus 16 and take a square root. So it's a 20. So c is 20. Oops, you can't see it. C is 20, b is 12, and a is 16. And that is one of the harder problems to do. Hopefully, you can see that the beginning is not too hard. The hardest part, honestly, will be this right here. This foiling out and multiplying, because you'll probably do it and then you'll be like making one mistake and you'll mess it all up. All right, that is the end of 4.4. And now I just want to take the last few moments to do some review questions for the quiz that you have. Let's see. I'm ready. Don't. Where did it go? Give me 1 second while I find it. I have all my papers running around here. What did I do with it? I literally just had the sheet, and now I don't know what I did with it. Oh, let me see. Hopefully my dog didn't eat it. Ah, I found it. Ooh. Okay. Because I try to go through the review basic quiz and I try to see certain problems that I'm like, oh, they might forget how to do this. Okay. So I'm not going to write all the directions, but this is essentially what they're going to give you. They want you to have a polynomial with a leading coefficient of 1, and they're going to give you zeros of 5 with a multiplicity of 2 and a 4 minus 5i. And they want you to write the polynomial. And you actually don't have to FOIL this out? What? How neat. I'm wondering if I'm tricking them. So if your zeros, don't forget, how do you write a polynomial if these are the roots, if these are the zeros? Okay. The conjugate theorem says that if I have an I, don't forget about, you also have its conjugate is a root. So I have x minus 1, 2, and then I have 5 with a multiplicity of 2, so that means I have x minus and another x minus. So I'm running out of room. 2 of the 5s go here and here, 5 and 5, because it's a multiplicity of 2. So there's 2 of them, 5 and 5. And then one of these roots go here, but you have to distribute that negative. So minus 4 minus 5i. This one would be minus 4 plus 5i. And I didn't FOIL it out. I left it like this. I actually just wrote it as x minus 5 squared. Now, if you have to FOIL it out, that means you'd have to distribute each one of these to all of these pieces and then distribute this. But I think you can actually just leave it in a factor form, which would be nice. Because I know that the tests are timed. So that wasn't hard. You just have to write it out. Don't forget to distribute that minus to the 4, minus to the positive 5i would be minus 5i, minus to the 4, minus to the minus 5i would be plus 5i. So you'll have a question just like that. Then you're going to have a question where they give you a polynomial, x to the 4th minus 6x cubed plus 91x squared minus 486x plus 810, and they're going to give you a 0, 3 minus I, and they want you to write it in factored form. So remember, you have how many complex roots? 4 of them. They only gave you 1. You know the other one though, 3 plus I. How do you find the other 2? You could go in Desmos right now and put this in and see if you have an actual root right there. But I promise you, you don't. You don't have it. It doesn't cross the x-axis at all. So that means you have 4 complex roots. Thankfully, you know 2 of them. So you are going to have to, and we did this last class, you are going to have to synthetically divide by the roots they gave you. And I showed you how to do it on the calculator, but I'll show you again. So you put your 1, negative 6, 91, negative 486, and then 810. I'm going to actually go like this. And I'm going to get out my calculator here. Remember, you can do the eyes on your calculator. So let's see. Move that out of the way. Drop this down. 1 times 3 minus I is 3 minus I. Now add these together. Negative 6 plus 3 minus I would be negative 3 minus I. Now you have to multiply these together. And let's just be on the safe side. 3 minus I, remember, is the decimal point, but you have to hit second I times times negative 3 minus I. And I get negative 10. Add these two, 81. Multiply these two. 81 times 3 minus I is 243 minus 81I. 81I. Now add that with a negative 46. So plus negative 486 would be negative 243 minus 81I. And now take that and multiply it with that one. Since it's already in my calculator, I'm just going to go times 3 minus I. And I hope, yes, I get negative 810, which makes a 0. Now, what do I do from here? Well, don't forget you have a conjugate, so you have the other 0 to divide by. And remember, this one should get faster at this point. So I'm going to use these 1, 2, 3, 4 numbers here. Negative 243 minus 81i. And I'm going to break it down. Let's see. 1 times 3 plus I is 3 plus I. Look at there. It goes to 0. 0 times that is 0. 81 times that is a positive 243 and a positive 81i, which goes to 0. Now, what have I just created? Remember, this was x to the 4th. This was x to the 3rd. Now I'm at an x squared. So I have x squared plus 81 equal to 0. And I would solve this. X squared equals negative 81. Sorry, when you bring it over, that's a negative. Take a square root. X equals plus or minus 9i. So there's your complex roots. You have 3 minus I, 3 plus I, the positive 9i, and the negative 9i. There's your 4 roots that you have to find. Like I said, none of them would be on Desmos, unfortunately. If it is, hey, go for it. Find it right away. All right. Last 2 quick questions on this review basic quiz. They're going to give you a polynomial. This one's easy. Negative square root of 3x cubed plus 5x squared minus 4x plus 4. And they're asking you for the end behavior. Oh, I can't even spell. Oh, my goodness. Behavior. So end behavior is super easy. You look at the highest degree, degree 3. It has a negative coefficient. All degree 3s, if they're negative x cubed, they'll start up and end down. If they were positive, it would start down and end up. So, and that's actually what you'll have to pick. That's your end behavior. Easy peasy. That one's a nice one. All right, and then the 4th one is they give you a polynomial. And I think they even factor it for you because I wrote it in factored form. Yes. But you could factor this by grouping this one and grouping this one. But you'd be left with x minus 2, x minus 1, and x plus 2. And then they ask you 3 questions. What is p of x equal to 0? What is p of x less than 0? Part B. And part C, what is p of x greater than 0? And this goes kind of along with what we were doing tonight. What are my answers to this polynomial when it equals 0? Well, it's easy. Just find your zeros. Your 0 would be, set that equal to 0, 2. Set that equal to 0, 1. Set that equal to 0, negative 2. Easy. What if you have an inequality? What if you have a less than symbol? Then you have to do a number line. Okay? I'm actually going to make my number line down here. So I'm going to put all my zeros on this number line in correct order. Negative 2, 1, 2. And I'm going to test my zones. Okay? I'm going to plug it in right here and put whether it's a positive or a negative. I'm going to do a sign test. So pick a number that comes before negative 2. I don't know, pick x equals negative 10. I always like to pick negative 10. So Negative 10 minus 2 is negative. Negative 10 minus 1 is still negative. Negative 10 plus 2, still negative. 3 negatives, keep it negative. Let's do this one. We're just gonna do them all, and then we'll answer this question. Negative 2 to 1. I don't pick 0. 0 minus 2 is negative. 0 minus 1 is negative. 0 plus 2 is positive. 2 negatives times a positive make a positive. Pick 1 to 2. So like 1.5. You'd have negative, positive, positive. You'd have a negative number. And then this one would be pick a positive number. So again, just picking numbers. Now let's answer the question. Where along this line would you have numbers that are less than 0? Less than 0. That would be the negatives, right? So all of your answers would be from negative infinity up to negative 2. The other negative would be 1 to 2. Put a little union. Where would all your answers be greater than 0? Well, that would be where the positives are. Here and here. So that would be from negative 2 to 1, united with 2 to infinity. And that's how easy that question should be for you. And like I said, I think you have one more on like just factoring. Hopefully you'll be able to get that one right.